Hello everyone, this is Vasanth, a nine-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to solve problems from fluid mechanics from the quiz 1 of IIT Bombay. So these are the questions of quiz 1. We already solved some questions in previous lecture. Today we are going to solve some more questions of this quiz. So before solving questions of this today's questions, let us understand 3D part of these questions. So there are different types of fluid which behave differently under the action of shear stress. Suppose this is du by dy and this is tau shear stress. Then there are different types of fluid. One flow will show the behavior like this, a straight line. One fluid will show behavior like this. One fluid will show behavior like this, and another fluid will show behavior something like this. One will show like this, another shows like this. So these are different types of fluids which behave differently under the action of shear stress. So if you see, this has tau is equals to mu into du by dy, right? So this is Newtonian fluid. In fluid mechanics, we generally assume fluid as Newtonian. So this is Newtonian fluid. Okay. If you see this figure, in this figure, tau will be is equals to some a into dou u by dou y whole power n whole power b. Okay. In this case, b will be greater than 1. And if you see this one, tau will be is equals to a dou u by dou y whole power b. And in this case, b will be less than 1. Okay. If you see over here, as you increasing the shear stress, in this case, the shear strain is increasing, right? So means if you say reverse, in reverse, as the strain is increasing, the value of shear stress is increasing, right? Means the shear stress is increasing on increasing the shear strain rate. This is so. This is tau is equals to this is known as dilatant fluid, and this dilatant fluid is also known as shear thickening, right? Because the shear is increasing on increasing the dou u by dou y. And this is known as pseudoplastic fluids, and this one is also known as shear thinning. Okay, and this one is known as Bingham plastic. So if you see these three diagrams over here, up to certain value of shear stress, they are resisting the shear stress, right, under equilibrium. After that, they are deforming under the shear stress. So this is known as yield stress. This is known as Bingham, and this is known as theopetic fluid, and this is known as thixotropic fluid. Okay. So if you want to know about this, in this case, tau will be is equals to some constant k plus a into dou u by dou y whole power b, right? In Bingham plastic case, the value of k will be is equals to 0 and b will be is equals to 1, right? So in this case, the value of k will be not non-zero, but b will be greater than 1. In this case, b will be less than 1. So these are different types of fluids which behave differently under the action of shear stress. Now let us solve these three questions. The fluid whose apparent viscosity increases with increase in the deformation rate is known as. Deformation rate for a fluid is given by dou u by dou y. Okay. So there is a fluid for which apparent viscosity increases with increase in the deformation rate. See, what is the viscosity, that will be tau divided by dou u by dou y, right? This is viscosity apparent. So in this case, for dilatant fluid, the apparent viscosity will be tau divided by dou u by dou y will be is equals to a into dou u by dou y b minus 1, right? So the b is greater than 1 for dilatant fluid. So on increasing the deformation rate, the value of shear stress will increase, means the value of apparent viscosity will increase. So this is the right answer. For suppose if you take pseudoplastic fluid, for that b will be less than 1. So on increasing the deformation rate, the value of apparent viscosity will decrease, right? So similarly, ideal fluid, what is the graph for ideal fluid? For ideal fluid, on application of small amount of shear stress, the fluid can't resist that shear stress. It will undergo indefinite deformation, right? So the ideal fluid diagram will be this one. This will be ideal fluid, right? And this one will be ideal solid. Ideal solid का meaning ये है कि that is rigid. Rigid solid. Rigid body will does not undergo any deformation under any action of load, right? So this is the answer for first question. Let us move to second question. So this is the second question. The spectacle wherein a person is shown to run across the pool of liquid without falling in is often achieved through the use of non-Newtonian fluid. What type of fluid is this likely to be? See, if you are running on the fluid, you should not fall in. You should run on the fluid without any falling in, right? So in this case, see, if you are running with some velocity, if you fastly run, then the value of dou u by dou y will increase, right? Because of that, if shear stress increase, then we can run on the fluid without any falling in, right? So this is the case of shear thickening fluid, means the value of shear stress should increase with increasing velocity. Because what happens when shear increases, the fluid will become thick and it will act as a semi-solid, right? Then you can run on that fluid. So for without falling in, you should run fastly. If you run slowly, then the fluid stress will become slow. Then the amount of thickness the fluid will have, that will become low. Then you will fall in. Okay. So to understand this more, just go to YouTube and type shear thickening fluid. Then you will find a video on which people will run on that fluid. You will get understand how this works. So this is question number 2. Now let us go to question number 3. In the experiment to determine the rheological behavior of a material, so studying the behavior of fluids under the action of shear stress is known as rheology. Okay. So the observed relation between the shear stress and the rate of shear strain. Rate of shear strain is given by dou u by dou y. Is tau is equals to tau naught plus dou u by dou y. What type of material is it likely to be? We already discussed if tau is equals to tau f plus some a into dou u by dou y whole power b. If b is equals to 1, then tau is equals to b is equals to 1 and tau is equals to tau naught is equals to tau f, right? Okay. So this will be tau naught plus a into dou u by dou y. So this will be Bingham constant. So the answer for this question will be, for Newtonian fluid it will be tau dou u by dou y, right? For ideal fluid it will be tau is equals to 0. For pseudoplastic it will be tau is equals to tau naught plus a into dou u by dou y whole power b, where b greater than 1, right? So with this we end today's lecture. In next lecture we are going to solve remaining problems of this quiz. Thank you.